Hello, welcome to the course Introduction to C++. Today we'll see how to get started by writing a simple program in C++ on Windows. Basically, we will be creating a console application. So let's see what is a console application first. A console program is basically a command line program, or it's also called CLI sometimes. This is where you type the commands to see the output rather than pointing with your mouse and rather than looking at icons or working with icons and images. We'll use command line interface because it's easy to get started in programming using console programming. Later on, when we feel confident enough, we will move over to the graphical user interface, which is more like the Windows interface with icons and mouse and drag and drop and stuff. Let me show you what a console window is like if you are not familiar. Okay, I'm having a problem with the mouse. Yeah, okay, sorry, there I got it. So this is your console window with the blinking cursor and you type commands. So we can lose the output of a particular folder. And if you want to change into a folder, we can do the cd command and the folder is changed. The path of the folder is displayed here. C is the drive in which we are located, and these are the folder names. So I am inside on the C drive, on the C hard disk, inside the folder users, inside the folder your username, inside the subfolder videos, and then what files are there in this folder, I can type dir to list the files. Okay, so basically what do we need to get started programming? The most basic tool is a simple text editor. We just need to type some commands and be able to save those commands on the hard disk. There is another tool that we need. We need a compiler, but we'll come to that in a minute. So text editor is simple. It allows you to type text, whatever you want to type. You can even type stories if you want to. But since we are learning C++ programming, we'll try to write some C++ commands rather than writing stories at this time. So we can use our favorite editors like Notepad or Notepad++ or WordPad or whatever other editor you like. But having said that, there is a issue with ordinary editors that especially which will be very useful for new programmers that these ordinary editors do not provide any help to new programmers or any kind of help even for experienced programmers. So we have something called integrated debugging environments or IDEs. So this is a special kind of an editor for programmers which provides syntax checking or command checking whether we are typing the correct command or not. And it also has most of the time a built-in compiler. A compiler is a software tool which translates the high-level programming language instructions into low-level machine code that can be executed by the computer. Okay, so let's talk about compilers. Computers are general, like if you want to program a general purpose computer, you will need to tell it what to do. And to tell somebody what to do, you need to be able to speak their language, right? The same is true for computers also. The language understood most easily by computers is ones and zeros, or machine code as it is sometimes called, or binary. But humans, we like to communicate in natural languages like English, Spanish, French, Swahili, or Urdu, or whatever language you are comfortable in. But we need a way to tell the computers in a high level language or something close to high level language what we need the computer to do, and then the compiler can come over and translate that into something low level. So compiler is a multi-step process. Sometimes you will find two steps only, sometimes you will find four steps in the compilation process, but generally it's a multi-step process which translates a high level language like Pascal or Python or C++ also. C++ is slightly difficult than Python, you can say, but it is still a high level language because it uses words from the English language dictionary. So those commands are more close for humans, or rather easier for humans to understand rather than the computer. So the high level language, whatever that program may be written in, is converted into lower level languages into using a series of steps, using some intermediate stage like assembly language. Assembly language is an intermediate stage. You can directly program in assembly language also, but uh, in this compilation process, in this figure, is shown as an intermediate step. It's slightly more difficult than C++ also because you have to keep track of addresses and where the data is coming and going from. And once we have it in assembly language, the later steps of the compilation process, the assembler and the linker, they produce the final executable code. So in Visual Studio, if I go back to the previous slide, we have several editors like Microsoft Visual Studio is one popular IDE for C++. We have Microsoft Code, which can be used for many different programming languages. And we have Dev C++. So one of these we will be using in our coming sessions. So once we have these compilers and the editor and the IDE, it's a multi-step process. For C++, it's usually a two-step process. The first step is the compilation, and the second step is the linker. Okay, let's look at a very simple C++ program. On the right hand side over here in this area is a C++ program which will print a simple message on the command line interface. It will print this message, hello to the C++ world. All the text inside the double quotes will be shown on the screen. So what are the remaining items in this area? So let's try to break them down one by one. So I will discuss some of them, and some of them I'll postpone discussing until a later stage. For now, let's start with the include directive. Include directive actually includes a pre-built executable library with your program. So our program needs to know what is the console or the command line interface. These four lines by themselves, they don't have any idea what is the console. So we need to include something already available in the C++ language system. This is called IO stream. So we are simply including that by giving the include reference to it. And then the second item is the main method. Okay, C++ programs are made of methods. A method is, you can think of it as a paragraph of commands, a sequence of commands, or a group of commands. So the main method has this syntax: int main and then parenthesis. There are some strange looking parameters inside. We don't need to worry about these for now. For now, I'll ask you to just accept that as they are. We will be going over them in later sessions. So we have int main and the parenthesis and this strange looking sequence. And then after that, we have the curly braces start and the curly braces end. All right, now the convention is that all the text characters, they start from the upper left hand side of your program. So they will start from this hash sign. Then I will proceed to the right hand side, one character at a time. And the cursor has reached the angle bracket, and then there is an empty line, another empty line, another empty line, and then there is the int keyword and then the main keyword. And then I'll scroll to the right hand side from the left side to the right hand side until I reach this curly braces here. And then I have four more lines with some having text and then the final curly braces. So this ordering is important. So this is how the compiler will also treat your program from left to right, top to bottom. So the main method is nothing but the word main preceded by int. What is this int? We haven't discussed that yet. We will come and discuss that in a bit. And it is followed by some strange looking parameters. Again, we haven't discussed those. And the important thing is that the body of the main method is written inside these curly braces. So this whole strange looking thing is known as the method signature, including the name of the method, which is main in this case, and the return data type, which is integer in this case. I am sure you are familiar with what are integers. Yes, 0, 1, 2, 3, 4, and so on. And also the negative numbers, right? Those are integers. So it is going to return an integer value. So the return type comes before the name of the method, followed by any parameters that need to be given to that method. So parameters we haven't discussed yet, so let's ignore those for now. So you can say that for getting started, you need to, in a sort of way, get this signature memorized for now. That's just the first step. We are just getting started, so it's okay, I guess. We can put some things in our memory without without worrying too much about what it actually means. So just to get started, let's do that. Okay, then let's go inside the body of this method. Inside the curly braces, we have the std namespace, std and cout. Cout is the actual command which will show some text on the command line display. So what is the command line display? So I'll bring it in here again. So this is the command line display, right? So if you want something to appear here, like for example, this message, Microsoft Windows version, whatever, we need to have this command as cout. Cout is included in the std namespace. Okay, so namespace followed by colon colon, that is the colon symbol 2 times, and then we can give it the command that we want to show on the screen. Now, if we give it this command without anything at the end, we can do that. Let's actually see how this will look like. So let me bring in the dev C++ editor. Okay. This isn't working. Let's switch it off. Okay, let's use it here. Okay, so this is the dev C++ editor. I'm using this because it's slightly easier to get started on Windows with dev C++ rather than using Microsoft Visual Studio. So let's start with a new project. We'll choose console application and we'll give it a suitable name. Okay, we need to give it a directory where we want to save it. We'll create a new folder. And we'll save it. Okay. You can see that already a skeleton code program is already created for you by the IDE. So in this case, this is just a comment. Okay, comments are written like this with slash asterisk, and they are ended with slash, sorry, asterisk slash, and in between them you can write them whatever you want. And these comments are ignored by the compiler. So for now, we'll just try to focus on what is happening here. We are including the IOStream library, and we have two comments. We can ignore these for now. And we have the main method signature, and followed by the curly bracket, and we are returning 0. This is the skeleton program, right? So if I execute this program now, oh, I need to save it again. And save it in the same folder. Okay, you can see at the bottom here that the program is compiling. Okay, there were 0 errors, 0 warnings, and the compilation time was this much. And okay, it took the output to the other window. I'll bring it back in. And you can see that the output is showing nothing. And this is the message from the C++ IDE, which controls the CLI output. So it's basically not showing anything at all and just printing the output messages. So I'll close that and run it again. Okay, it's taking again to the other window. Okay. Okay, now let's type that message that we saw in our slides, right? We have to type this message or anything similar. So we'll type std colon and then colon one more time, cout, and then two less than symbols and then double quotes. You see that I typed double quote only one time and automatically the IDE brought in the matching double quote to close this string. So I'll type a message. Okay, I can stop over here. To terminate a command in C++, we use colon. I can do that, but there's a problem with this without the ending sequence here. Let's see what happens. Let's save and execute. Okay. Something didn't go right. Okay, actually I didn't compile the program, so I have to compile the program. Compile. Now I can execute or choose F11, compile and run. Okay, the issue with the console, let's go into the other window. Okay, so now you can see that the message that we typed appears as it is on the line. Uh, Now if I type something else other than that, let's say I want to type a second message. Let's save and execute and compile and run. Okay, as you can see that both the messages are on the same line. This is, if this is your intention, then okay, you can go ahead like that. But actually what I wanted was to have it on a new line. To include the new line character, I'll simply put in an additional parameter and L, and you can also put it in the other one if you like. And that will add an extra new line character in the end. Let's close this, execute. Okay, so there you go. The program is now compiled and is showing outputs on separate lines. Okay, let's go back to the slides for a minute and have a look at the second program. So We saw how std namespace has to be added every time before we use cout. So there is a way around that. We will look at it in a minute. So cout function actually shows output to the screen, or it can be to any stream actually, not just the screen. It can be to a file also. Endl constant adds a new line character to the end of the message. And finally, we have a return zero statement. If you look at the main method signature, its return data type. The data type in the beginning is int for integer. So this means that this method must exit by returning something. So if you don't have anything to return for an integer value, you can return a zero over there, right? So we are returning a zero. If there was an error in the program, we might want to return an error code or a negative number or something different in that case. Okay, let's look at the second program. The second program is a slightly more one step higher, you can say, one step higher version of the same simple program. We are using data types. What are data types? We have already used the int data type before in our first program, integers, right? We can also have other types of data in our program. We can have characters or char, or we can have strings or a sequence of characters. Plus, we can have floats, we can have floating point values, Boolean values, and so on. But to get started, just let's see how we can work with strings, and let's talk about variables also. A variable is a storage space which is given a name in the computer's memory. So computer memory can be anything like 4 megabyte or 4 gigabyte to 16 gigabyte or 32 gigabyte, whatever, depending on your computer, right? How do you identify where your data is located in all of that 4 gigabyte memory space? You need to have the address of the memory or the name of the memory location. So variables are convenient way for programmers to reference their data. They give names, which is nothing but an address pointer or an address location for their particular data type. So variables are named locations in memory. So on the right hand side, you can see that we are having a string data, a string variable called your name, and the name given in this case is elf. So it can be any, you can substitute this with whatever you like, but the variable name will be using later on. So the program programming is becomes more interesting because we can work with variables rather than data items themselves. So over here, what are we doing? We are including the IOStream library and we are including the string library also. String is actually an extension to C++ data types. Originally, C++ didn't have string. It's not a standard built-in primitive type. It is included via libraries. So we have to include that library. And the rest is, the only other difference is we have one extra line over here in the beginning, the third line, using namespace std. If you go back to the previous program, we were using cout, and every time we use cout or some other command from that library, we had to use std. That is the standard library. Std colon colon and then cout, std colon colon and then endl. But if we have many usage from the same library, we can simply say using namespace and then whatever the name of that library. In this case, it is std. So using namespace std colon, and now we can use cout without using std before it. Uh, in the first program, we talked about these variables that we said that we'll uh, memorize them for now. So what are they actually? These are actually arguments or parameters. Parameters for this method main. So parameters can be of two types, formal parameters and actual parameters. So parameters are, you can say, more or less like variables, like this variable here, string your name. It's a location in memory. But parameters are different from variables also in the way because they are passed as input or output from your program or from your method. So arguments are special kind of variables which are passed as input or output from your program. So formal parameters are the placeholders. For example, over here we have integer argument c or argc. This is a formal parameter. Suppose I have another method where I am calling the main method. So I can call that main method by using an integer, a fixed value 4, for example. I can say call main and then in the brackets I can put 4, or I can pass another variable of integer type. So that will be the actual parameter that gets passed. So we'll discuss this more later on when we talk about functions and methods in detail. So we have methods and method return types we have already seen. So let's go back to our editor and convert this program, or let's type, uh, okay, we'll convert this program into our second form. We don't need these comments actually, so I'll just delete these. First, I need to include string. Let's say I make a mistake and I type B string by mistake. And then I try to declare a variable here of string type. Okay, so variables can be passed in to the stream also. And we want to use the namespace. So we'll use using namespace std. And then we can remove this, or we can leave it also if you want. But since we are using std, so why not remove it? Let's leave it in one and remove it in others. We'll just add some arbitrary text. after that also, just to show how it is going to replace. Okay, so I remember I made a mistake here, B string. So let's try compiling and see how the error messages look like in dev C++. Okay, so you see the IDE did a fairly good job in locating the location of the error, and it's highlighted the line where the error is. And if you look at the bottom side, it's showing the line number and the column number where the possible source of error is. Sometimes this gets misleading, so it's generally showing the area or the first error, but sometimes you have to trace back from that line number given here to get the actual error. But generally, yes, it helps. This line number is the actual source of error in this case. So there are two errors over here. We can see that B string is no such file or directory, compilation terminated. And second one is saying main.o failed. So if you remember the compilation process, the high level language or the high level code in this case is in main.cpp file, which will be translated into intermediate object code main.o file, which is failing in this case. So from main.o, the second step would be to produce the main.exe file. So let's open the folder to see if we can have a look at the output. Okay, so you can see here, this is the main CPP program and this is the main O program. Now these are from the last compilation, so these are already there. So let's see if we can clean it. No, I guess not. That's a feature in Visual Studio, not in Dev C++. So we can simply delete them here. Let's delete them here. Yeah. And go back in Dev C++ and try compiling again. So again, we have the two errors, and you can see that the main.o file and the main.exe file is not being created. So let's remove this error now. Save it and execute, or rather compile one more time. Okay, so there are no errors now, and it also produced the output. Let's close that. Okay, and you can see now there's the main.o file, the intermediate object file. And after that, in the last step of the compilation, the executable file was produced. So if we run this file, uh, it's showing on the other screen. Oh, because we don't have a read character statement at the end. It exited. So let's do it through the IDE. Compile and run. Okay. So here we have our output messages: hello C++ world, alf, comma, and then the space. If you compare it with what we wrote in the program, you can see how it works. So your name is a variable name which is being replaced by the value in the memory. And the memory is storing the value on line number 7. The value is alf. So your name is replaced by that value. So this is how variables work. Okay, now I ran it through the command line using the IDE. So it's not closing the window. It's saying press any key to continue. So it is waiting for my input from the keyboard. right? So if I run it directly in my folder, it just starts the console, executes it, and since my program itself doesn't have any waiting mechanism, it immediately exits. The windows will just flash on the screen and then close again. That is the normal behavior of an executable. So you are able to see it here through the IDE because the IDE itself is adding this part, the wait mechanism. So where you have to press a key for it to continue. So if I press a key on the keyboard, now it exits. But if I click here, you will just see a flash and yeah, there it went on the other screen. It's closed now. So later on, we will see how we can add a simple line over here to take input from the console. So the net effect will be that our program will not immediately exit because it is waiting for input. So that's it for now. Uh, I don't have anything else for today. So if you have any questions, you can contact me through email or some other mechanism and let me know. Thank you so much.